I'm Charlie. Tonight on BBC News, we have...
Tube drivers striking leaves the whole of the London Underground empty. More evidence has been found on the Mark Davis murders crime scene. Crisis is spreading in the Middle East. But now, a disastrous oil spill in the Gulf of Mexico.
In the Gulf of Mexico, near the Mississippi River Delta in the United States, a wellhead blowout on an offshore oil rig has caused 11 casualties and up to 4.9 million barrels of crude oil has spilled into the sea. This is the largest ever accidental marine oil spill in the history of the petroleum industry. There was extensive damage to marine wildlife habitats. Many rescue efforts have been made to save the many birds that are washed up on the shore covered in oil. BP have settled criminal charges for $4.5 billion. But what is crude oil? I will now be questioning Joe Burgess, who is an expert in the area. Hello, Joe Burgess.
Hello, Charlie.
Hello. So, what is crude oil?
Well, crude oil is a thick, dark brown liquid found deep in the Earth's crust. It's a mixture of different hydrocarbon molecules made of hydrogen and carbon. Some molecules in the mixture are very small. For example, methane, which is a carbon atom and 4 hydrogen atoms. Others are more complex. For example, octane, which has 8 carbon atoms and 18 hydrogen atoms. But as a mixture, it's completely useless. Oil is a non-renewable resource, which means they will run out.
So, why do we drill for it if it's useless?
Well, you see, we fractionally distill crude oil to separate the different size molecules within the crude oil.
How do you do that?
The crude oil is heated to a vapour. Different sized molecules will have different boiling points. The smaller the molecule, the lower the boiling point. So as they are heated, these smaller molecules start to turn into a gas and rise up. The further they get from the heat source, it starts to cool, and the molecules condense back into a liquid and are piped into separate pipes. As the molecules, which are probably known as alkanes, get larger in size, the flammability decreases, the boiling point increases, and the viscosity increases. The volatility decreases, and the smokiness of the flame increases. The smaller alkanes are more useful because they ignite more easily, so they can be used as fuels like petrol and liquid petroleum.
So, you say the smaller alkanes are more useful. What do they do with the larger alkanes?
Some large alkanes can be used for tarmac. Bitumen, it comes out of the bottom of the fractional distillation column. However, when we have the very large alkanes, we can crack them. Cracking is breaking the large alkane into a smaller alkane and an alkene.
Okay, so how do you crack?
Well, you have to pass the alkane vapour over a hot catalyst. It splits through thermal decomposition.
How can you tell that it's happened?
Alkenes can react with bromine, and the bromine water goes from orange to colourless. Alkenes are unsaturated because they have a double bond which can break and then bond with the bromine molecule. They turn bromine from orange to colourless.
So, what do you do with the alkenes?
I'm glad you asked. The double bond breaks in lots of monomers and they join together to form a long chain polymer.
Ooh. So, what are polymers?
Well, polymers are very long chain molecules. For example, polyethene. The ethenes react with each other to make a long chain, polythene. Do you recognise that?
Yes, I do. Polythene bags.
Yes, exactly. We use alkenes for plastics. You can get 2 types of plastics, thermosoftening and thermosetting. Thermosoftening plastics melt easily and they have weak forces between the chains. It is used in carrier bags. Thermosetting plastics burn or char when heated. They have a strong cross links between the chains, holding them in fixed positions. It is used for things such as fuse sockets.
So, we use plastics all the time, but are they non-biodegradable? How do we dispose of them?
After we've used plastics, we either reuse them, recycle them, landfill them, or incinerate them. If we recycle them, it saves energy and reduces landfill waste, and it saves resources. Landfill is quick and easy, but we are running out of space to use landfill. Incinerating plastics generates thermal energy, but it can also release toxic gases.
So, we shouldn't use plastics as much as we do.
You're right, but that is very hard. We have become so used to using them that it would be hard to stop. There are some items we wouldn't have without crude oil. We have some examples over there. Now, over here we have some examples of things that use crude oil. We have a toy over here. Around Christmas especially, when toys sell lots, we're using a lot of crude oil.
Yeah, you're right.
We also have pens, which are made out of plastic,
Yeah.
and sellotape, which also uses plastic. Now, other things we use in everyday life that use crude oil are things such as vehicles, which burn high quality fuels such as kerosene, but with lower grade vehicles, we burn things like petrol.
Oh, well, thank you, Joe. You've been such a great help.
That is no problem, but now I have to go and inform the rest of the world about the dangers of crude oil.
Thank you for watching BBC News. Goodbye.